Number 33, you're subtracting two binomials with i's in it. We're subtracting, so we got to distribute the negatives. So we write the first binomial as 2 plus 4i minus 4 minus 7i. Combine the like terms. 4i minus 7i is negative 3i. 4 minus 2 is negative 2. So your answer is going to be negative 2 minus 3i for number 33. Number 35, it says simplify the radical expression and use absolute value symbols when needed. We use absolute value symbols when dealing with the variables when we take a square root. So, square root of 64 is 8. When we take the square root of a variable, you divide the variable exponent by 2 when it's even. So 10 divided by 2 is 5. So x to the 5, you put that in absolute value bars. So your answer is going to be 8 absolute value of x to the 5th. The 8, it says to multiply and simplify and to assume that all variables are positive. And that's the case because if it were negative, we'd be dealing with the imaginary numbers. So multiply inside to inside. So 5 times 12 is 60. If 5 x to the 5th times x to the 4, you add the exponents. So it'll be x to the 9. Now what we do is we subtract 1 from an odd exponent to take the square root. So the largest perfect square factor of 60 will be 4. So we have square root of 4 times square root of 15 times square root of x to the 8. That's the 9 minus 1. And then this will be that x to the 1 that came out. So square root of 4 is 2. Square root of x to the 8. Divide 8 by 2 to take the square root of it. You get x to the 4. So we have 2x to the 4 square root of 15x. And that is my answer for number 38. Skipping to 43, it says rationalize the denominator and to simplify if possible. So we have 7 over radical 5 plus 2. Now, to rationalize it, we will be multiplying by conjugate. The conjugate would be radical 5 minus 2, so multiply top and bottom by radical 5 minus 2. So up top, we'll have 7 radical 5, and then 7 times negative 2 is negative 14. At the bottom, we'll have radical 5 times radical 5, which is just 5, because radical 25 has a square root of 5, and then 2 minus 2 is negative 4. So then 5 minus 4 is 1, which leaves us with just 7 radical 5 minus 14 as the answer for number 43. Number 46, to get x by itself, we need to first get this radical by itself. So to do that, we need to add 4 to both sides. So we have radical 5x plus 6 equals 4. Then to get rid of the square root, we square both sides. The square root of 5x plus 6 being squared just gives you 5x plus 6, and 4 squared is 16. So then we subtract 6 from both sides, we get 5x equals 10. Divide both sides by 5, and we get x equals 2. So the answer for number 46 is 2. 47 says to simplify the rational expression and to state any restrictions on the variable. So what we need to do is factor the bottom, the denominator, and to do that we take out a GCF of 2x. So we have 2x over 2x times 2x minus 1. To find the restrictions, you will set each of the factors in the denominator, which is the 2x and 2x minus 1, equal to 0, and then solve both of them. So you'll have x cannot equal 0 and x cannot equal 1/2, because we cannot have 0 in a denominator. So now that we found our restrictions, then we can simplify. 2x over 2x will reduce to 1. So we would have the simplified rational expression of 1 over 2x minus 1, again assuming that x does not equal 0 and x does not equal 1/2. And that is number 47. Number 49 says to simplify the sum and state any restrictions on the variable. Denominators are the same, so we just add the numerators. So 6w plus w is 7w, 5 plus 6 is 11. So 7w plus 11 over w minus 7. Now to find the restrictions, set w minus 7 equal to 0. Add 7 to both sides, you'll get w not equaling 7. You can add 7 down at the bottom to give you 0 down here. So the restriction is w cannot equal 7. Number 50 says to solve the following equation. So, since they had the same denominator, as a shortcut, we could simply cross out the denominators and then set the equation 11 equal to x plus 4. Then subtract 4 from both sides, and you get x equals 7. Now let's check our answer. Substituting in 7 for x, we have 11 over 7 plus 1 equals 7 plus 4 over 7 plus 1. So you'll get 8 as your denominators and 11 on top. So you have 11 over 8 equals 11 over 8, which checks. So 7 is the answer for 50.